Welcome into the channel, everyone. Even though I hate to talk about it and I hate to show it, today I'm going to teach you how to properly weave it wide and wish it weld when it comes to MIG and Flux-Core. You might recognize this place. We're at the Hustling and Bustling Precision Welding Academy here in Houston, Texas. We've got some plates in front of us. Here are some 3G welds. We're going to do one side with MIG, one side with Flux-Core. This is half-inch plate, and these bevels are close to an inch wide, probably about 7/8 of an inch. We're going to put one big old wide weave on that thing. We're going to do one with MIG, one with Flux-Core, because I think it's important, if you do think you're going to weave something, to do it properly. I would say I'm always on team stringers. Like, I'm not trying to weave nothing. You guys let us know down in the comments whether you think weaving's faster or you think stringers are faster. Which one's better? I'm team stringers, but today we're gonna weave the snot out of it. So let's go to the machine first and get it set up for MIG, and then we'll move on to the welding. The machine that we're gonna end up using today for both MIG and Flux-Core is gonna be the Rustler 280 Pro from ESAB. We're gonna be doing a longer weld today, so I'm definitely gonna go to that trigger and hit that 4T. Basically, I can hit that trigger and let go, and then we can keep going. My goal is not to stop while we weld so we can get the best weave that we can. We're gonna go ahead and set the voltage somewhere around 19 and 220. I like these settings for a vertical MIG, 035 size wire. If I notice I get a heavier crown or it's high in the middle, I might bump these settings down, or I might try some different motion. But we're gonna be working in kind of a short circuit and globular transfer, so there's gonna be a ton of spatter. We don't want a bunch of spatter on our plate, and anti-spatter is the trick, right? If you have a nasty nozzle, you're gonna have some issues when you're running vertical and you start dragging that gunk and stuff through it. So we wanna make sure that our nozzle is clean. So I've got my nozzle all picked out, cleaned out. I also noticed that the contact tip was giving me some guff when I was tacking my plates together. So I got a new contact tip for the 035 size wire. And then I'm gonna put this eWeld 3 stuff from Walter on here. The nice thing about this is it's methylene chloride free. I don't know if y'all know what that even is, but it's kind of a sweet smelling chemical that they put in the anti-spatter and a lot of industrial stuff. And that stuff's toxic for you. It can cause cancer and a lot of other issues. Walter is eco-friendly. And what it really breaks down to is there's no methylene chloride in any of this stuff. So I got this other eWeld 3 stuff. This is, I mean, I put this stuff on freaking everything. I put it on my plate, I'll put it on my fab tables, I'll put it on just about everything to keep it from sticking. I even sprayed Scott a little bit. He thought it was, he didn't like it. But we went ahead and did a little bit of a root pass on these plates. I did one side with the spatter, anti-spatter, one without, and I think it's clear as day. Doesn't affect the weld. We've got no spatter on one. We got a lot of spatter on the other, especially working in this transfer mode. I want to keep this thing pretty much spatter free. So we're going to be using this all along the way. Now we got the machine set up. Let's get to the business end of stuff over here. Now we've only got about 6 inches of weld here, maybe a 6.5 or so. But these welds still feel like they take ages to do. That's one of the big reasons why we had that machine set to that 4T trigger, so I don't have to sit there and hold the trigger the whole way up. And maybe I don't even realize it, but my hand gets a little bit tired and lets go, and then I have to make a restart. I don't know if y'all remember this video that we did a while back about properly weaving your 7018. There's gonna be a lot of similarities into that. Right now we're in a groove weld. We don't have enough room to really weave out a lot. With this short circuit process, almost globular kind of thing, if we start weaving too wide right now, we're gonna catch lack of fusion, we're gonna miss some pieces and maybe get lack of fusion or miss penetration. That's a big deal. So we don't want to be going too wide on this first pass. We're going to actually work it in like a Christmas tree pattern. Once we get the first pass in here, we're going to have a lot more room to pause and move and do that zigzag that you're probably used to seeing. It is going to be a long weld, so have some pretty thick gloves. Keep your hands out of the danger zone. We're going to try to maintain a perpendicular angle all the way up, even with the oscillation that we're doing. We do not want to lean this gun back at all. We don't want to start dragging it. I like to think we want to be right in it. A little bit of a lean up, like a 5-degree up, is not going to be too bad. It's not going to hurt you. Try to not put your elbow on something that's going to limit you, and get your hand a little closer. I like to put my shoulder on something so that I have a lot of movement, but I'm still braced. Kind of tuck your elbows in and then channel your inner robot. Try to just figure out that oscillation and maintain it, maintain the angle, maintain that travel speed. Let's weld. Once we get a puddle started, it's almost like a weave where we're kind of doing more of a horseshoe. Coming up, filling up at the top, just trying to put a nice good base in here. I don't want to pile up in the middle, so I have to get across that weld as fast as I can. I don't think the settings are that bad. I think we're all right. So you can see how far I'm coming out of that puddle, but I try not to disconnect my weld from that puddle at all. I might be coming up and away a lot, but I'm trying to make sure that puddle is still stuck together, and I get across that section as fast as I can. Let's check it out. Give everything a quick jimmy to see how we did. What I'm really looking for is to keep the undercut to a minimum. If I see an undercut in these edges, that means I need to be over there and filling a little bit more. And if I see that I'm piling up a little heavier in the center, I need to get through that spot a lot more. I'm not necessarily trying to weave a whole heck of a lot, but I'm trying to oscillate and still stay in my puddle, because this is a really crucial part of that weldment, and I want it all to be fused together. So this is fairly flat. At the bottom there, I don't like that, so I'll end up switching over to a Cubitron 3 cut grind and flattening anything that I see that I don't like. And it was mainly just down there at that bottom. If you want a nice, flat, smooth weld, you have to weld over something that's nice, smooth, and flat. We also caught some porosity down here at the bottom. I'm gonna get rid of that, fill it back in, blend it back down, and then we'll move on to really weaving that thing. You got the porosity out, guys. I don't really care if you're just practicing. Don't weld over porosity, especially that early in the joint. Get it out, fill it back in. I did end up turning my machine down to 18.4 and 200. I'm liking the way that's carrying a little bit better. Again, it's a short circuit process, so we are getting some spatter. I think that porosity had a little bit to do with the fact that all of that stuff piled up right there at the start. I'm gonna try to be a little bit more on the edges there with this stuff. It looks like it's working on the nozzle too. Get a little bit of that wire out, clip it, and now we can go ahead and start doing our big weaves here. Got that 4T trigger on, so I've let go of my finger, and I'm coming over and I'm putting a nice sized nugget, and then I'm going to go over to the other side and put a nice big nugget. I'm really spending very little time in the center of this weldment. And at this point, our weave really isn't that wide. The thing we got to make sure we don't do is go too quick across and leave a low spot, or go too slow across. Every time you touch the left side once, the right side once, you've crossed the middle twice. The middle usually takes care of itself. This is definitely weaving at this point. But I think this is about the max that I would ever like to weave before I'd start switching into stringer beads about this size maybe. As you get closer to the top of the plate, you're going to notice your gun angle is going to want to lean back. Don't let it lean back. It just takes forever, guys. I'm catching hella porosity up there. I don't know what all that business is about. Alright, after we got all this porosity fixed, it just was only happening to me here at the top. So I moved my sucker up a little higher, and that seemed to fix things as I was getting up towards the top. But what we really want to look at is the difference between this part right here, this part. Don't even look at that part. It's just kind of messy up at the very top. We're going to keep that consistent on the next layer. But you can tell down here, I'm low in the middle. That means I went too fast across. Right in here, this middle section is what looks the best to me. I want to try to make sure that these steps going up are not too high up. You can go farther up in your zigzag. You just got to pause a little longer, right? You can do a tighter zigzag and you don't have to pause as long, but we always want to be pretty much quick across the middle. Now, the wider we get, the slower across the middle that you're going to have to stretch things. This almost feels like it's so wide, I'm just kind of stacking horizontal beads. It just seems like a silly thing to have to do. Just keep on keeping on with this right here, getting to the left side, holding it. Slow bead to the right side, holding it. Slow bead to the left side, holding it. The biggest fear you should have with weaving this much is just getting too far out of your puddle and not tying into these steps that you're making. You're making huge, massive steps, carrying a bunch of metal. Kind of like more money, more problem. More metal, more problem. I think it takes too long and it makes me want to fall asleep. I hope this looks good because I have no idea what it's going to look like. I just can tell you it's taking forever. There's some more porosity up there. Why are you doing that? I don't know if you're a welder out there that does any of this type of stuff with short circuit MIG on heavy plate, weaving this freaking wide. I think this is an absolute obsolete process. There are better ways to do this with wire fed stuff. You know, there's low spots in here that I don't like. Of course, if you have any small low spots in those fills, you're gonna see them on your cap. I see a little bit of undercut on this side. If you don't come over far enough and give it enough fill, you're gonna undercut too. Not my shtick, man. I'm not a big fan of doing these big, long, wide weave welds with MIG. It is sometimes kind of cool to look at, but let's get a better look with a little bit of this wire wheel. Give it a jimmy real quick. See these nasty wide weaves, man. Even when you buff the ugly off of it, it's still not my thing. We're good to go to the machine and we can switch it over for some dual shield Flux-Core. Let's do some big old weaves with that monster. So I went ahead and swapped out the wire. We've got 045 dual shield Flux-Core, 75-25 gas, pretty much a basic setup. We've got it run through. The drive rollers are swept to 045. ESAB color coats them, so it's kind of easy and welder proof to make sure you have the right size rollers running through there. We got it all the way fed through. Made sure we got a new contact tip. We put a new nozzle on and then sprayed a little bit more of that good stuff on there. Now the biggest difference on this is we're going to go up in voltage here. I'm probably going to start somewhere around 23 or 24 volts. I think that's going to be good. And then somewhere around 250. I don't want too much amperage right now, too much punch, because we only have an open root MIG in there, and I don't want to blow a hole in it with this hotter process. So I think that's going to be plenty right now. We're not going to be doing those big weaves and pauses like we did with MIG. Flux-Core's got a little bit of a different technique. And it's a lot smokier too, which led me to look at the filter gauge on this Donaldson fume extractor, and something made me raise a little bit of question. Now in my older years, I'd like to think I'm trying to stay a little bit safer. And you guys have probably seen this Donaldson fume extractor in a few of our videos as I helped donate it here to Precision Welding Academy. This gauge here is what's supposed to tell us when these filters are ready to be swapped. And from what it looked like, this thing's been here for almost a year, and it's been used. As you can see, it's been used. And the gauge really hadn't moved a whole lot. I know that I got some spare filters for Scott, so I just went to start pulling things out. These all came out really easy. Once they're unscrewed, you just slide them out, and boy golly, did those things look nasty. I don't know how much life they had left in it. The filter gauge said it still had a lot, but I don't know about all that because they look pretty gross. I made a little bit of a mess. I probably should have put gloves on because they were pretty filthy compared to the new ones that I saw. The new ones were super easy to slide back in, put together. Like overall, like a filter swap probably take you a minute if you had everything on hand and already out. So we got the filters swapped now. It's important to keep everything maintained as you go about using equipment. As long as you can do a lot of preventive maintenance, you're gonna have a piece of equipment that lasts a lot longer. So I think we can probably get rid of these filters and continue with the Flux-Core. I got this sucker flip back on. I swear it's got some more lungs now. Like it's looking better. I hope I don't get any bright ideas, and I don't want to see any more porosity today. So there should be enough distance here. When we were doing the MIG welding, we were really kind of focusing on getting up and out of that puddle, but not too far disconnected with it and going away and pausing and pausing. With this process, especially on this first pass, I love just some oscillation, baby. Keeping it side to side so that wire doesn't get too punchy through the middle there. But all I'm going to do on this first pass is just go straight up, and this is the motion I'm doing, this side to side wiggle, trying to hit each side, each toe of that root pass that I did before. And I just want to really bounce off the thicker parts of the steel, but I don't want to pause really anywhere. This is a much hotter process. It'll lay down. I don't want to climb out of my puddle. I want to stay more in the puddle, if anything. Let's do that wiggle. Quick wiggle, wiggle. Wiggle, 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 wiggle. I don't want to get too far ahead, too far back. Oh, that's what happens. Big hole city, hole city. Oh, that sucks. Gotta love watching me put some holes and stuff. You know, even Tom Brady makes mistakes every once in a while. All right, now that that's haphazardly fixed, I did go ahead and bump down my volts and my wire feed. Now we're at 23 and 215. Still gonna keep that same technique. Try not to bust through this plate again. Definitely feels a little cooler, so that's nice, I guess. If I even catch a whiff of some heat, I'm gonna stop. And have a little bit of an angle down for a drag angle. Doing that quick oscillation again. Oh gosh, that's gonna fall out. Really trying to get to those edges. The thicker sections of metal is where home is. That thin root there where I did an open root MIG weld downhill. Just there was nothing to sit on, so just being a little bit cautious, maybe a little overly cautious, but we got that first pass in. The point that was supposed to make was that we're not weaving. We still don't have enough room to weave. Don't bother weaving at this point. You will trap slag and you will have problems. Evidently, if you do it this way, you'll have problems too. Jumping in right into this next pass, nothing's really gonna change. I don't really wanna do this big wide weave. I'm gonna actually show you what I don't wanna see versus how we're gonna end up capping it here. So what I'm doing now is kind of doing exactly what we did with that MIG and just kind of going side to side, pausing on the right side, pausing on the left side. We did bring our volts and our wire feed back up from 23 to 24 and 215 to 250. We have some material in there, so now we can kind of have a little bit more heat. This really isn't all that hot, but it was for that little root that we had in there. This process is going to fill up a lot faster, so it is nicer the fact that we're dumping a lot more material and I'm not going to have to sit in one spot. But this, in all my years of welding and stuff, this is not how I like to see my dual shield Flux-Core welds turn out. And as a CWI for 9 years, and if I look at a weld that's got these big massive steps, especially with a process that involves, you know, flux and slag, and I would prefer to see all those steps to be a lot tighter. I don't want to see those cool ripples and dimes or whatever you want to call it. I want to see smooth. Got some good news and bad news, folks. I don't know if you saw at the very end of that last weld, I got to the top and stopped, but it was just a volcano of just garbage, porosity, the word of the freaking day. I ground it out and fixed it, and at this time the students had all went to lunch. It was a little quieter in here and I could hear it. Just over yonder at my gas bottle, I could hear the leak. Wasn't my fault. I had to go give Scott Robbie, the owner of Precision, a hard time. Scott, it wasn't my fault. It was this thing. It was this.
Welders always blame the
It was the gas, dude. It was pissing out that end.
Yeah.
But we got it swapped out. I swapped out the regulators. We got a better one on. I did fix this spot. It seemed to even weld a little bit better. I don't know what it was with that little hole in it, but it did seem like, I felt like I was welding hot and I didn't even want it. So we're gonna cap it now. I also have used fume extractors before. That should not be that high to pull too much shielding gas. And I've used anti-spatter before. That should not be a problem when welding. The stuff is easy to weld over. So I'm gonna put it all on there again because I want to see this no porosity, because it was definitely that regulator. From the previous pass, you could see those big steps in there. I'm not a big fan of those big lumps. So that's what we're gonna do different on this weld. Unlike what we did on the MIG, we're not going to take those big pauses. We are just going to move side to side at a nice constant rate. That little bit of side to side action that we do and hitting that edge is the only pause we really need. I'm hoping that regulator swap is definitely going to nip everything in the bud. I don't know if you guys can tell, but I'm just casually bouncing side to side. I'm keeping my wire inside the bevel edge. I know behind this big puddle I'm carrying, it's stacking up pretty heavy, but I definitely want to make sure that I get to those edges. I want to see that puddle roll out about 1/16 of an inch, and then once I see it kind of time that little bit of a roll outside your edge, then you can kind of get in that rhythm. Try not to lean back or favor left to right. I know I'm right-handed, so I'll usually favor pointing to the left because my elbow will stick out and you get a lopsided cap. Like if you see my right elbow now, how it's tucked to my body, that's going to definitely change my torch angle, so I'm going to try to keep it tucked. This just felt like a lot smoother of a weld, and I'm going to credit that to this regulator thing that we kind of fixed up, because that felt like how it should have been, and I have been fighting this the whole time. I mean, the slag fell off that. That's the way I would weave something. God, I almost wish I could redo this whole freaking video, because I fought it today, guys. And I try not to cut any of it, but I fought it today. That's more like it. That's what we should have been seeing this whole freaking time. This isn't a really hard process, and really weaving is not difficult with these 2 wire fit process, but I was fighting that. Man, that sucks that we fought that all stinking day and didn't figure it out to the cap. The nice thing about this only being a YouTube channel, this wasn't a real job for me. So I try to hope you live a little bit vicariously through me and see the mistakes that I make on the basis of someone who's done this often. You got to check your equipment. That should be the number one. It's in almost every book. Before you get started, check your equipment, make sure it's working properly. Otherwise, you're going to waste a lot of freaking time. But that's the weld that I would want to see if I had to make a big, fat, wide one. I don't want to see those ripples. I want to try to see everything as tight as possible. Less stress risers. I think it welded really smooth. I think that you're staying in your puddle more, less likely to trap slag. That's the bead that I'd want to see, but I'd still be like, oh, dang, that's big. Let me know if you ever use either one of these processes to weld this wide, like an inch wide welds, and that's acceptable. Not that you do it on the side or you like doing it, but you do this for work and that's how they want it. Let me know in the comments below, because I think this is crazy. This is something that I can wrap my head around. This short circuit MIG doing the verticals, I think that's obsolete. I think that's a valuable lesson learned. Check the equipment first. I should have known better. Fume extraction doesn't pull that much away. Like, it's not close enough. It's still getting everything it needs. The anti-spatter, I've welded over that with a lot of different processes and not gotten any porosity. The wire was brand new. What could it have been? It had to have been the gas. I should have checked it. I should have been on that sooner. But I do think the techniques were all still there. Guys, if you like what you saw today as far as the episode and some of the techniques, or maybe give me some advice on what you'd like to see next. If you want to learn more about the equipment we use, like the Donaldson fume extraction system, the ESAB Rustler, or even some of this Walther anti-spatter, it's all down in the link below. I want to raise my spirits a little bit. I'm going to go around and bless some of these students with a bunch of anti-spatter. Let's go Oprah Winfrey some of these folks. You get some, and you get some, and you get some. Got it all loaded down. Go hook them up. Need some of that? Any more? Who's working? Who's working? What up, homie? Here's some anti-spatter, free on the house. Oh. You need some anti-spatter? And keep the BBs off that TIG weld. Free anti-spatter. Need some of that? That's for you. Now you need some anti-spatter, sir? That'll keep the boogers off your beads. Sure enough to make your weld slicker. You need some slick weld sauce? You get some anti-spatter.
Oh, thanks.
You get some anti-spatter.
Thanks.
You get some anti-spatter.
Thank you, sir.
And you get some anti-spatter.
Thank you.
You bet. Keep the boogers off your beads.